So does the recent breakthrough in fusion mean that we've solved climate change? So I know it's been forever since I posted a video, but I figured this is a good time to get in on the conversation when it comes to fusion, even though I'm a little late on the draw there as well. You might have heard that there is a lot of rhetoric going on right now when it comes to the recent fusion breakthrough at the National Ignition Facility. And I'm hearing some very interesting things when it comes from both the anti-nuclear side as well as the pro-nuclear side of things. Let me start out with saying that the milestone reached by the National Ignition Facility was a major one. What happened was the energy that came out of the fusion reaction at this facility was greater than the energy of the lasers going into the system. The reason why that this is such a big deal is because this has never been accomplished by humankind except for in a thermal nuclear bomb. When it comes to a lot of the rhetoric that I've heard around this story, I have rarely heard anyone with good nuance about what this really means. What's interesting is you have kind of two sides of the argument here. You have the media, which has been pushing this as a huge accomplishment that means that we are just on the brink of accomplishing fusion energy that's going to power us into the future. And an interesting dynamic that I am seeing here is on the very opposite end of the spectrum are both pro and anti-nuclear individuals arguing that this was no big accomplishment at all. One argument that I've seen over and over again on the anti-against side is that this facility is specifically designed to test out nuclear fusion for weapons research. Now, there is a little bit of truth to this, but it's missing a lot of nuance. The main purpose of this facility is for weapons testing because we can't actually do weapons testing because then we would be violating treaties. And the way that they've developed this facility wasn't really looking towards making this specific fusion design into a power reactor. But the big thing is that just because an experiment or something that was done was for weapons purpose or for military purpose doesn't mean a lot of good couldn't come out of it. Take Chicago Pile 1. It was the first self-sustained critical reactor that humans ever made. And for years after that, because of the Manhattan Project, a lot of fission reactors were created that their sole purpose was for weapons production. And now nuclear power for peaceful purposes has come out of this. We could actually owe a lot of things to the Manhattan Project that we still use today. Take Teflon, for example. Before the Manhattan Project, it was extremely expensive to make, and you only made a small amount of it in a laboratory. Because the Manhattan Project required some sort of material that didn't use oil in the valves that handled the uranium hexafluoride, which is extremely corrosive, they needed some new material. The Manhattan Project was the first application of Teflon. You might be able to argue that it would have taken us a long time to finally get to the point where we're using Teflon on our pots and pans if it wasn't for the Manhattan Project mass producing it. There have been countless other inventions that have also come out of wartime research, such as radar and GPS. So just because something is specifically for a wartime use or developed for the military doesn't mean that a lot of good couldn't come out of it. Then there's another criticism that counters the media's portrayal that we have reached the holy grail of fixing climate change when it comes to this fusion accomplishment. And it's actually pretty valid. So in this specific experiment, the amount of energy in the lasers going in was 2.05 megajoules, and the amount of energy that came out of that pellet was 3.15 megajoules. That would give you a gain of about 150%. But that's not the whole picture. The amount of energy that it took To produce those 2.05 megajoules of laser energy was over 400 megajoules. So it was actually less than 1% of energy gain. A lot of people are trying to compare this breakthrough experiment to the Chicago Pile 1 experiment, which was a self-sustained reaction. The Chicago Pile 1 experiment, the moment that they were able to achieve self-sustained reaction, they didn't have to put any more energy into it. They could have allowed that thing to keep on going and it would stay at self-sustained energy without any more input. This was not the case at the National Ignition Facility. For the National Ignition Facility design of fusion reactor, once you put that energy into those lasers, into that pellet, the pellet is destroyed. You actually have to continually put another pellet in over and over again, many times per second. And those lasers have to keep shooting every single time as that pellet is destroyed. It actually takes days and days to get those lasers to do one shot. But a big thing is, these lasers that they're using at this facility are like 1980s technology. We have a lot more efficient lasers that we can use. So let's say that we decide to upgrade to some newer lasers and we're able to get a higher gain out of that pellet than 3.15 megajoules. And finally, at some point, someday, we do achieve a gain that is greater from that fuel pellet than the amount of energy total that we're putting into it. The tokamak reactor, which is a different type of fusion reactor, probably will achieve that point. Unfortunately, there'd still be a lot of work to do. When it comes to any sort of heat engine, which this would be a heat engine, you have to produce actually a lot more heat than you put into it in order to have useful energy. This is because all heat engines have efficiency losses of at least 50%. So even if you did reach that breakthrough where it's more energy in that fusion system than the energy you put into it, you need to double that amount in order to be able to produce enough heat that can produce steam that can then turn a turbine and produce electricity. In order to achieve this sort of design that's able to actually produce enough energy, it needs to be bigger and bigger to the point where it costs a ton of money to create this reactor. So yes, this is a big accomplishment for humankind, but there's a lot of work to do. And do I personally believe that this is finally that holy grail and we're going to solve climate change using fusion? I don't think so. I can't predict the future, but everything that we know at this time says that the answer is no.